Okay, we're getting ready to do Chapter 6, additional practice problems for chemistry. So the first question is convert a temperature of 75.0 degrees Fahrenheit to degrees Celsius. Okay, so you are permitted to have the formulas on your index card. So the formula for degree C is 5/9 times the Fahrenheit temperature minus 32. And that 32 is an exact number. So we'll just go out to the ones place. So it's going to be 5/9, and 75 minus 32 is 43. And so then we take 5 times 43 and divide by 9. And what you should get is 23.9 degrees C. But because so you can have just two significant figures. We're multiplying now. So with two significant figures, then the temperature in degrees C would be 24 degrees. Okay, the number 2 says that we are to convert a temperature of 1,420 degrees C, convert that to Fahrenheit. So the temperature, the formula for degrees Fahrenheit is 9/5 times the temperature in degrees C plus 32. Okay, so 9 times 1420 divided by 5 will give us 2,556. However, we need to do significant figures just for our multiplication, and this has only 3 significant figures. So that this would need to become 2,560, and then we add our 32 to that. So both of these numbers go out to the ones place, so our answer will also go out to the ones place. So 2,560 plus 32 is 2,592 degrees Fahrenheit. Okay, number 3 says the temperature of gas A is 1,115 degrees Fahrenheit, and the temperature of the same gas is 700.0 degrees C. Which gases molecules are moving faster? So can't compare those until you get them into the same unit. So it doesn't matter whether you change the Celsius to Fahrenheit or change Fahrenheit to Celsius, but you need to get them into the same unit. So I'm going to change the Fahrenheit into Celsius. So degrees C is equal to 5/9 times the Fahrenheit temperature minus 32. So 1,115 minus 32 is 1,083. Both of these go out to the ones place, so we're subtracting, so we go out to the ones place, and then we multiply that times 5/9. So 5 times this divided by 9 will give us 601, and then repeating 6's. And we can have 4 significant figures, so it's going to be 601.7 degrees. Okay, so that's degrees C. So this gas is this, and we're comparing this to this, And in which one will the molecules be moving faster? Well, we know that the higher the temperature, the faster the gas molecules will be moving. So this gas will have the faster moving molecules, or the gas. It's the same gas, but that gas at this temperature will have the faster moving molecules. Okay, number 4 has multiple parts, so there are 5 parts to it. Part A says solid aluminum reacts with liquid hydrogen monobromide. So hydrogen monobromide, and it makes aqueous aluminum bromide and gaseous hydrogen. Okay, so you know hydrogen is a homonuclear diatomic, so that needs to be that. But then let's go back here and at the aluminum bromide, and you should recognize that as a homonuclear diatomic, as an ionic compound. So aluminum's in group 3, so it has a charge of +3. Bromine is in column 7A, so it has a charge of -1. So we switch the charges. So the formula for aluminum bromide then would be AlBr3. Okay, and then we're ready to balance it. So let's see, we had 3 bromines over here. Let's get 3 here by doing that. Now we have 3 hydrogens over on the product side, and we have 2 over here. So we can fix that by getting 6 on each side. So let's put a 3 here. And then let's change this to a 6 over here. Okay, so that makes our hydrogens okay, but we messed up our bromines. So we can fix those bromines by having 2 aluminum bromines. So now we have 6 bromines on each side, but now we messed up the aluminum. So we have 2 aluminums on the product side, so we can get 2 aluminums on the reactant side. So now that equation is balanced. 2 aluminums, 6 hydrogens, 3 times 2 is 6 hydrogens, 6 times 1, so we have 6 bromines, and 2 times 3, 6 bromines on that. Okay, then 4b gives us this equation to balance. Okay, so on each side we have potassium, oxygen, hydrogen, and phosphorus. So let's see where we are when we start. So potassiums, we have 1 on this side, and we have 3 over here. Oxygens, we have 5 on this side, and we have 5 on that side. Hydrogens, we have 4 on the reactant side, and we have 2 on the product side, and then phosphorus is 1 and 1. Okay, so let's start by fixing the potassium. So we have 3 on the product side, so let's get 3 over here. Now that's gonna, that will mess up some of the others, but at least for now, the potassiums are okay. So now on the oxygen, we have 3 plus 4, which is 7. So we have 7 over here, and we have 4 plus 1. So we still have 5 over there. Hydrogens, we have 4, and we have 2. So let's put a 2 here. So that gets our hydrogens up to 4. And now let's see what that did to our oxygen. So we have 3 plus 4. So we have 7 oxygens over there. And we have 2 plus 4. So we have 6. Is that right? Three, 4. Oh, actually, I take that back on the hydrogens. We have 6 hydrogens over here. So we have 3 plus 3. So we have 6 hydrogens over here. So to get 6 over here, we can put a 3 here. That gives us 6 hydrogens on both sides. So now let's look at our oxygen. So now we have 3 plus 4, which is 7. And we have 3 plus 4, which is 7. So everything should be okay now. So 3 potassiums, 3 potassiums. We have 3 plus 3 is 6 hydrogens. And we have 3 times 2, 6 hydrogens there. 1 phosphorus on each side, and then if we look at the oxygens, we have 3 plus 4 is 7, and 3 plus 4 is 7. So that is the balanced equation there. Okay, 4C is you were given SeCl6 plus oxygen will give us SeO2 plus 3 plus chlorine. Okay, and we know you have to remember that actually I think they give it. I think they give you that as chlorine gas. Okay, so then we have selenium, chlorine, and oxygen on each side. So we start out with 1 selenium on each side. We have 6 chlorines over here. We only have 2 over there. And oxygens, we have 2 and we have 2. So we can fix those chlorines by going like this. That gets that there. And I believe that's all we need to do for that one. Selenium's 1, 1, chlorine 6, and 3 times 2 is 6. And the oxygens are 2 and 2. So that one is balanced. Okay, 4D is C9H20 plus oxygen will give us CO2 and water. Okay, so you should recognize this as a complete combustion reaction. So there's sufficient oxygen that the carbon becomes carbon dioxide and not carbon monoxide. So if we look at trying to balance this now, let's look at the carbons, the hydrogens, and the oxygens. So on this side we have 9 carbons, on this side we have 1. We have 2 oxygens over here, and we have 3 over
here. So 2 and 1. And then oxygens, wait, hydrogens we have 20 and we have 2. And then oxygens we have 2 and we have 3. That's right, okay. So let's fix the carbons first. So that if we put a 9 here, that gives us 9 carbons on each side. And now let's see what that did to the rest. So our hydrogens are still okay. We have 20 and we only have 2 over here. So let's make this 10 waters. So now the hydrogens are 20 and 20. And now if we look at the oxygens, we have 2 and we have 18. 2 times 9 is 18 plus 10 is 28. So we have 28, we now have 28 oxygens over here. So we can get 28 over here by having 14 oxygens. 14 times 2 is 28. So that is now balanced. Okay, 4C, we are told that we have iron, solid iron, iron 3, remember, and iron is a transitional metal. So it can have various charges. So they're telling us what this what the charge is, and it's iron oxide. So the first thing we should do is just get the formula for that. So the formula, the charge on the iron is +3, and oxygen is in group 6A, so its charge is -2. So we're going to switch those charges. Iron is Fe, so Fe2, and then oxide would be O3. So iron oxide reacts with carbon monoxide gas and produces solid iron plus carbon dioxide gas. Okay, so that's what we start with. So we have iron, oxygen, and carbon on each side. So the iron, we have 2, and we only have 1 over here. Oxygen, we have 4, and we have 2. And carbons, we have 1, and we have 1. Okay, so let's go ahead and fix the irons. We'll put a 2 here. So now we have 2 irons there. Carbons are okay. We have 1 and 1, but we have 4 oxygens and we have 2 oxygens. So if we try to get, we have 4 and 2. If we put a 2 here, that's not going to, that'll give us 4, but it's going to mess up our carbon. So if we put that there, now we have 3, we have 5 oxygens, and we have 4 oxygens over here. So let's try
let's try 3 carbon monoxides and 3 carbon dioxides. So now we have 3 plus 3, so we have 6 oxygens over there, and we have 2 times 3, which is 6 oxygens over there. Our carbons, we have 3 and 3, and the irons are still okay at 2. Okay, so Fe2O3 plus 3 carbon monoxides will give us 2 irons plus 3 carbon dioxides. Okay, then going on to the next page, we are asked to write some balanced equations for different types of reactions. So the first one is, where I did those. The first one is for the formation of sodium nitrate. So to form that, it's going to form from sodium plus nitrogen plus oxygen is going to give us NaNO3. However, you have to remember that these are both homonuclear diatomics. So now we can balance this equation. So sodiums are okay. Nitrogens, we have 2 over here, 2 on the reactant side and only 1 over here. So let's put that there. Now we have 6 oxygens on the product side and only 2 over here. So we can do 3 oxygens there. And then if we just put a 2 in front of the sodium. So 2 sodiums, 2 sodiums, 2 nitrogens, 2 times 1. Nitrogen is 2, and then 3 times 2 is 6, and 2 times 3 is 6 on the oxygen. So that equation is balanced. Okay, then next is the decomposition of C3H8O. Okay, so decomposition is just the opposite of formation. So it's going to break down into carbon plus hydrogen plus oxygen. And again, we have to remember that these are homonuclear diatomics. So we have 3 carbons over here. So let's put a 3 here to get our carbons okay. We have 8 hydrogens over here. If we put a 4 here, that gives us 8 there. And so then oxygens, we have 1 and we have 2 over here. So let's put a 2 here. That gives us 2 oxygens and 2 oxygens, but it kind of messes up the carbon, so we can fix those now. So we have 6 carbons, so let's do 6 carbons, and now we have 16 hydrogens over here. 2 times 8 is 16. So to get 16 hydrogens over here, we can make this 8 hydrogens. So now we have 6 carbons, 2 times 8 is 16. 2 times 8 is 16 hydrogens, and 8 times 2 is 16 hydrogens, and then we have 2 times 1 for the oxygen, so 2 oxygens over here and 2 oxygens over there. So that's the balanced equation for that, for the decomposition of C3H8O. Okay, next is the complete combustion of gaseous So it's the same compound we were just looking at, but now we're going to combust it, complete combustion. So complete combustion means that we add sufficient oxygen that we end up with CO2 plus water. Okay, so let's see, carbon, hydrogens, oxygens. Carbons, hydrogens, oxygens. So we have 3 carbons here, we have 1 there, 8 hydrogens there, and 2 there. And then we have 3 oxygens here, and we have 3 there. Okay, so let's start by fixing the carbons. So we put a 3 there, and now we have 3 carbons on each side. I did this one so I can make sure we're together on it. Okay, so we're okay on the carbons. Now if we if we put a 4 here for the hydrogens, that makes our hydrogens okay. We have 8 on each side. But now if we look at the oxygens, we still have 3 on this side, but we have 6 plus 4, we have 10 on this side. Okay, so let's double everything. Well, actually, is that going to work? So we have 10. Yeah, let's go ahead and double everything and see what that does for us. Well, actually, you know what? Before we do that, let's try to get. We can get 20 oxygens by, if we put 9 here, then that gives us 18. And then if we double this, that's going to give us 20 oxygens on this side. And if we double that, then we also have to double everything else. So we're going to double this, and we will double this. And that should give us what we need then. So let me go ahead and write that out again. So let's look at our carbons. So it's going to be 2 C3H8O plus 9 oxygens will give us 6 carbon dioxides and 8 waters. So now if we look at our carbons, hydrogens and oxygens on each side. So over here we have 6 carbons and we have 6 carbons. We have 2 times 8, which is 16 hydrogens. 8 goes up here. And over here we have 2 times 8, which is 16 hydrogens. And now if we look at the oxygens, we have 18 plus 2 is 20. And we have 12 plus 8, which is 20. Okay, so that's a more difficult one. We had to, since we had 10, we started out with 10 over on this side. We had to come up with a multiple of 10 on this side. And to do that, we took the 9 oxygens, and then we doubled this to pick up the 2 more. That gave us 20 on that side. Then we needed to double each of these, double this and double that, because we had also doubled that. Okay, then number 6, the last one, just gives us a series of reactions and asks us what type of reaction it is. So magnesium plus copper chloride gives us magnesium chloride plus copper. Okay, so looking at this, the copper and the chloride were together. Now the magnesium and the chloride together. And so that is a single displacement reaction. Okay, the next is 6 carbons plus 6 hydrogen gases and oxygen gas will give us C6H12O2. So in this reaction, we are combining elements to come up with a compound, so that is a formation reaction. Okay, the next one is AgNO3 plus NaOH, which is sodium hydroxide, gives us silver hydroxide. Ag is silver, plus NaNO3. Okay, so the silver was with the NO3, now the sodium is with it, and the sodium was with the hydroxide, and now the silver is with it. So it was a double switch, so it's a double displacement reaction. Okay, so C6H12O2 is burned with oxygen, and the products are carbon monoxide and water. So this tells us there was insufficient oxygen to produce carbon dioxide, so it produces the poisonous gas carbon monoxide, so this is incomplete combustion. And then last one is, here's the balanced equation. Silver hydroxide okay, so there's our equation. So we start with silver hydroxide, and it breaks down into silver and oxygen gas and hydrogen gas. So this is a decomposition reaction. Okay, that's all of the additional practice problems for chapter 6.